Let's do a quick review of UDP before we talk about some of its vulnerabilities. UDP is a connectionless transport layer protocol. When we compare it to TCP, what we find is that UDP does not have any reliability, flow control, or error recovery mechanisms. And because of this, the fields that we would see in a TCP header that are used for those features are not present in a UDP header. Therefore, we have less overhead than TCP when we use UDP. The header is very simple, and the checksum value is optional. UDP is commonly used by DNS, SNMP, NFS, and TFTP, as well as with real-time applications such as voice over IP. Now, looking at the UDP header, what you'll notice is that we do have a very simple header. And we said that this UDP checksum here, this 16-bit UDP checksum, is something that's optional. Now, the data inside here is data that we create that checksum off of. So therefore, an attacker could modify the data that's inside this header and simply replace this UDP checksum. UDP by itself is not protected by any encryption. That would be something that you would have to add on. So therefore, it makes it real easy for a user to look at your traffic and basically put themselves into the conversation and inject certain types of data. Now, this is one type of an attack that we see with UDP, but most attacks that we see with UDP involve exhausting the resources on the network. So in this example, let's assume that we have an attacker, and the attacker machine wants to consume all of the resources on this network, on the subnet that this device is on, perhaps maybe on the subnet that the server farm is on. So what commonly happens is we'll use an application like UDP Unicorn, and it's going to let us send a UDP flood attack. So we have these UDP packets. Oftentimes the IP header information with our source IP address is going to be spoofed. It'll be some other host that's on this subnet or a host that's not present. And so the attacker will flood a server with these packets, just as many as possible, and it'll sweep the entire range of ports, hoping perhaps that the port is closed in this case. And what's going to happen when that port is closed is our server is going to reply back with an ICMP port unreachable message. When it replies back with that ICMP port unreachable to every single UDP segment that it receives, eventually it's going to consume a lot of the bandwidth that is on the segment here. Now, we saw an attack similar to this with the SQL Slammer worm. This was circa 2003. This is just a classic example of UDP flooding. So that SQL Slammer would eventually flood that network. Now, it did involve more than just flooding the network. It involved a buffer overflow attack and then a flooding of the network from there. But again, it's just another example of how UDP is commonly used as a vulnerability or commonly exploited. So the two attacks that we typically see here is data manipulation with a brand new checksum, as well as the exhaustion of resources with UDP flooding.